This video is for MA 108, Section 5.1. We are talking here about inverse sine functions, inverse cosine functions, and inverse tangent function. First, let's look at the graph of the function y equals sine of x. So this is the graph of the function y equals sine of x. This function is not a one-to-one function. It is not a one-to-one function because it fails to pass the horizontal line test. In other words, if I drew a straight line, I can cross the function in more than one place. For example, at the origin, it crosses the function in more than one place. A horizontal line that goes to the origin crosses the function in more than one place. So this is not a one-to-one function. However, if I restrict sine of x on the domain of negative pi over 2, including negative pi over 2, to pi over 2, then I have the sine function that's been restricted. In this case, I have a modified or a special sine function. So we've restricted that domain, negative pi over 2 to positive pi over 2. Now, y equals sine of x, restricted on this domain, is a one-to-one function. And if it is a one-to-one function, it has an inverse. We call the inverse of sine of x the special name arcsine, A-R-C, sine of x. Arcsine of x is the inverse of sine of x if we restrict sine of x to this domain, negative pi over 2 to pi over 2. Another notation for arcsine of x is sine raised to the negative 1 of x. This function raised to the negative 1 notation is the universal symbol for an inverse function. Note, the inverse symbol, sine raised to the negative 1 of x, is not the same as 1 over sine of x. This would be the reciprocal of sine of x. This is not the reciprocal. This is inverse function notation. Okay. If sine of x and arcsine of x are inverses, then when I put in arcsine of x inside sine of x, that's the same thing as putting sine of x inside arcsine of x. And the result of that would always be x. This is saying each one of these separately. Arcsine of x inside sine of x, the domain of arcsine of x is between negative 1 and 1. That produces x. If I put in sine of x, if I restrict sine of x on this pi over 2 negative to pi over 2 positive, then I get out, I put that inside of arcsine and I get out x. The same idea for cosine of x. So let me show a graph of cosine of x. So if I have cosine of x, this is a graph of cosine of x, and you see it is not a one-to-one function. But if I restrict the domain of cosine of x to be between 0 and pi, then I have a special case of the cosine of x function restricted from 0 to pi. Now this is a one-to-one function. And since that is a one-to-one function, that one-to-one function has an inverse. And we call that inverse arc cosine. So we restrict cosine of x from 0 to pi, including the endpoints. Then if we put in arc cosine inside a cosine, or we put in cosine into arc cosine, those are inverses of each other, we get out x. The same idea is true for tangent. So this is tangent of x. Now tangent of x is not a one-to-one function. And if I restrict the domain to minus pi over 2 to pi over 2, then I do get a one-to-one function. Notice I did not include the endpoints. This is less than, but no equal, greater than, but no equal. That's because tangent of x is not defined at exactly negative pi over 2 or at pi over 2. So it's on the open interval. Now I do have a one-to-one function, and very similar to sine and cosine, if I restrict tangent of x to this open domain from negative pi over 2 to pi over 2, then the arctan of x put inside the tangent function is the same thing as the tangent of x put inside the arctangent function, and I get out x.